In this interactive figure, we have two objects that are interacting with one another, an apple and an orange, and the orange is in a cart. I'm going to go ahead and hit the play button, and it's hard to see, but the apple is actually walking forward and pulling the orange. And I'm going to go ahead and show the net force on the orange alone. So what we see is a number of these bubble boxes that sort of appear and show and identify all of the different forces. So if I focus just on the orange has this dotted line around it, and the force that's acting on the orange, it has a net force, which is this red arrow right here, and that net force is coming from all of the forces that are acting just on the orange. So if we go through and we look at the forces that are acting on the orange, the apple pulls on the orange, so that apple is pulling on the orange. That's one thing that's acting on the orange. And the only other force that's acting on the orange is the ground pushes on the orange, and that's kind of like the friction from the ground right there. So we have two forces that are actually acting on the orange, the apple pulling, and then the ground kind of pushing back on the orange. Now, in this picture, part of the reason for looking at this is to consider pairs of forces according to Newton's third law. And we know that according to Newton's third law, that forces are always created in pairs. And so for every force on here, we should see the pair. And so we can identify pairs by basically just looking at the wording. So here the apple pulls on the orange, but if I look over here, the orange pulls on the apple. And down here, we know that the ground pushes on the orange, but the orange also pushes on the ground. So these are a pair of forces here. And then we have another pair of forces here. And then finally, if we look at the apple, we have the ground pushes on the apple, and the apple pushes on the ground. So we have three pairs of forces in this particular example. And those pairs of forces are always acting on different objects, right? So we have, for example, the ground pushes on the apple. That's the force on the apple. But then the apple pushes on the ground. That's the force on the ground. So pairs of forces are always equal and opposite and act on two different objects.